Hey everyone, welcome to Solving Systems of Equations. This is Mr. Bennett. This is part one in its substitution. We're really going to focus on the y equals aspect. There's different ways to solve systems by substitution, but for our intent and purposes, this is just strictly when both equations are of that form y equals, and that's really important to remember. Okay, so the goal today is you'll be able to solve a system by using substitution. And a lot of times we refer to this as algebraic, okay, by hand. So this is an algebraic way, okay? I've just got a couple of examples for you, so let's go ahead and get started. So our first system, solve the system using substitution, okay? So substitution, so notice how we have y equals and y equals. We're going to plug one thing in for another. So let's take a look. Notice that we have y equals negative 4x plus 8, y equals x plus 7. So here's our system. They have different slopes. So that means there has to be a solution. These two lines are going to intersect. So how do we do that? Well, essentially, we know what each y is. This y is equal to x plus 7. So why not just take this y and plug it in here? Now, I could have done negative 4x plus 8 and plugged it in here, but seems to be easier. So our equation is going to be x plus 7 equals negative 4x plus 8. I just rewrote the equation. Remember, this was y. This used to be y, but we know what y is. Y was x plus 7. So there's your substitution. Okay, so that's key. So now this is an equation with variables on both sides. So the goal here is to get the variable alone and the constant alone on one side. So we see variables on both sides. Negative 4 is less than 1, so we're going to go ahead and add 4x to both sides. So add 4x to both sides, and we get x plus 4x is 5x's. These go to 0. Okay, the plus 7 comes down. We haven't used it yet. Equals comes down, and the 8 comes down. So now this is an equation, a two-step equation. Notice how the variables alone, but we have the variables on one side, and now we have constants on both. So let's move the constant. So plus 7, you're going to subtract 7 from both sides. Okay, and we're left with 5x. These go away. 5x equals 1. So now we undo multiplication, 5 times x with division. Okay? And so we have x equals 1/5. Okay, that's just a crazy little variable there. Okay, our number, so 1/5. So how do we do that? 1/5 or 2/10. So if we wanted the y value, let's use the bottom of the equation. Let's use it for substitution. So this was part 1, we got x, but we need the y value. Well, y is equal to your x, 0.2 plus 7. So that equals 7.2. So our answer is just 1/5, 7 1/5. You could do it that way. You could write it as a fraction. So there's our answer, or not a fraction. You could write it as 0.2 and 7.2 in decimal form. So that's example number 1. So let's go ahead and look at a second example. That example was nice because it kind of goes through and shows you you can't always graph and get really nice solutions. So that's why we need other means. So again, we have two equations, y equals x plus 1, y equals 2x minus 1, and they want us to solve using substitution. Again, we can take this one here, we know what y equals, and plug it in here. So if we rewrite it, it's x plus 1 equals 2x minus 1. Now, the slopes were different, and remember, x plus 1, this was our y value. Y equals 2x minus 1. Well, let's just replace it. We just replaced it. They have different slopes, these two lines, so they have to intersect. There will be a solution. Again, an equation with variables on both sides. 1x is less than 2x's, so I'm going to move the single x over. And again, we want the variable on one side of the equal sign and the constant on the other. These go to 0. The 1 comes down. 2x minus x is just x, and you have a minus 1 here. And notice how we have the variable only on the right side now, but we have constants on both. So let's move the constant. Let's get the variable alone. So now you get 2 equals x. So a little friendlier example here. You're not done because you need the y value. You can use either one of these equations, but I'm going to use the top one because it's easier. So look, y equals my x. Well, x is 2. 2 plus 1, which is 3. So your solution is an ordered pair, 2, 3. That is the solution to the system. That's where both lines intersect. And that solution is going to make both equations true. Look, does 2 plus 1, so does 2 plus 1 equal 3? It does. Does 2 times 2 minus 1 equal 3? It does. It checks out. So hopefully that helps you with solving by substitution for systems. I'm going to send you guys 4 examples to do on Google Classroom. So if you have any questions, please let me know. We'll see you next time, guys.